All right, we're back. We're going to be on page 119 of Notes 11 in Math Analysis. But what I thought we'd do is I thought I would start in GeoGebra. So I'm in GeoGebra Classic. If you just go to geogebra.org, make sure you choose Classic. So I don't know, it says ready for tests. I don't know why it says that, but choose GeoGebra Classic because it gives you a lot of the options that we're going to need to be able to use. And so I'm in that. And what I'm going to do is I'm going to kind of create a thing here. So I'm just going to take I'm going to make a point. So click here and just, I don't know, click, right? So I have a point, and then if I go back to the move tool, I can just pick it up and move it. So wherever it needs to be. Okay. I'm also going to make a vector. And the way I'm going to do that is I'm just going to type vector. And then if I give it a point, it's just going to create a vector that starts at the origin and kind of like goes. So I'm going to say the vector is 3, 2, which I kind of took from I took that from the notes. There's a vector 3, 2. If you look at the picture in the notes on page 119, it's definitely a vector that says go 3 to the right and go 2 up. So we write them as ordered pairs. GeoGebra writes them as a 2x1 matrix. Either one's acceptable. I would prefer you write them as ordered pairs for our purposes, but you know, whatever. It's called a column vector instead of a row vector, whatever. So what I'm going to do is a weird thing. I'm going to create a vector. You see how it says starting point and ending point. So the starting point I want to be A. The ending point, I want the ending. So this is a weird notation. You have to kind of use it a lot so you get used to it. I want the ending point to be start at A and use the vector U. So this is what I wanted. So wherever A is, I'm going to move 3 to the right and 2 up to get to the ending point of my vector. And then I can actually put a point there. So if I do point, and then if I do point, so you see point, and then it takes point comma vector. So I'm going to say A comma U. And it'll put a point at the end of this vector. And that's where point B is going to be. So I can move the point A. That's literally the only thing I can change here. I can grab it and drag it around. I can't move B, because B has to be 3 units to the right and 2 units up from wherever A is. Like there's no alternative to that. So that's all I can do. So this is fine. And I'm moving it all over the place, right? And what I prefer though, what's the easiest way to talk about this vector, right? Like here, I could say it's the vector from -5, 3 to -2, 5. Okay. Here, I could say that this is the vector from -4, -2 to -1, 0. Totally fine. I'm just reading them off. I'm reading from A to B. You can see those in the column on the side. Here, I want to go from 1, -2 to 4, 0. None of these are convenient though. The most convenient thing to say would be it's the vector 3, 2, right? Go 3 to the right, go 2 up. To make that happen, if I take A and just put it at the origin, then the point B now is at the point 3, 2. The point B, if the initial point is the origin, is the vector. It's just communicating what we need to do. That's why our preferred initial point will always be the origin. Anytime you are creating your own vector, if you have a choice, try to make it start at the origin. You take any vector and just translate it back to the origin, right? Like if this is A is -4, 3. If I take A and translate it 4 units to the right and 3 units down and move everything accordingly, all of a sudden I'm back here. And now all I need to do to reference this vector is say 3, 2. The terminal point is 3, 2. This is telling us what we do. Move left, right, 3, move up, down, 2. Well, rather, you move to the right 3 and up 2. So that's how we're actually going to do this. Let me go to the notes and we'll take a look at the picture. I just wanted to show you a couple of commands that you can use on GeoGebra and also, like, you know, pick it up and move it, make it a little more dynamic. So we know that 2 vectors are equal if and only if they have the same magnitude and direction, which means that in this picture, I hate the way that I didn't get the T into. It means in this picture here, all of these vectors are the same, but one of them is the most convenient, and it is this one, because it starts at the origin. You really want that. So all of these vectors are communicating that we should go 3 units to the right and 2 units up. Every single one of them is doing that. So the one that we would use is the one that starts at the origin. And that form, super convenient, we call component form. So component form, I would say, is how you're going to write like 90% of your vectors. And all it does is it convey the information. Like, given the initial point, what do? You move 8 units in the x direction, you move 5 units in the y direction. You move -4 units in the x direction and 12 units in the y direction. Whatever it is, you just give the components, the first component, the second component. They're like the elements of a matrix. And it's pretty easy to find. We've actually been doing it a lot. So the key is you're going to do x2 minus x1. So this, I'm going to try to highlight this just to like make it really clear. The order matters a ton. So here, and then, I don't know, like this. The order matters. So you have to do terminal minus initial so that you capture whether you're moving to the left or to the right, or if you're moving up or you're moving down. Like, the order matters a ton, but it's convenient to think of it as just delta x, delta y, provided you remember terminal minus initial. Like, you have to do terminal minus initial. Where you stop minus where you stop. Have to do it that way. If you don't do it that way, you're going to get it wrong. Hopefully you do it consistently wrong, and then you just get kind of the opposite set of directions, but never mix and match. I mean, always do it right. Terminal minus initial. So here, fill in the blanks in this table. We know the initial point. Well, we know 2 out of the 3. We know initial point, terminal point, or component form. So in the first one, I know initial point and terminal point, so I'm just going to do terminal minus initial. So that's 17 minus 9, comma, 8 minus -12, which is 8 comma 20. So you move 8 units to the right, and you can like check it really quickly, like start at 9, move 8 units to the right. Yes, you end up at 17. -12, move 20 units up. Yes, you end up at 8. So we did it right. Another set of givens here is our initial point is 15, -3. We don't know the terminal point, but we do know the component form of the vector, which is telling us to move 8 units to the right, 7 units down. So here, I'm going to say that this ordered pair would be 15, move 8 units to the right, and then -3, move 7 units down. So we'll get 23, comma, -10. So that's not bad. Now the last one, there's a number of ways you can think about it. So here's what I'm thinking. I'm going to call this like xy. Right? Ooh, it's an ordered pair though, not a vector. You will find that over time you start thinking of ordered pairs as vectors. Hopefully, if you're thinking about it enough, eventually that will happen. So I know that if I do terminal minus initial, so terminal minus initial should give me component. So terminal minus initial, so if I do 2 minus x, and I do -6 minus y, that should give me -5, 8. Well, now it just feels like a matrix equation, right? Like if 2 minus x is -5, then x must be, I don't know, 7. And then if -6 minus y is 8, then y must be, why is this so hard? -14. So I think that it's 7, -14. And then you can check. So terminal minus initial, 2 minus 7 is -5, -6 minus -14 is +8. So we got them right. Now another way to think about this one, I think, is, so say we have an initial, and then what are we doing here? So the terminal point is 5 units to the left. So let's say this, and then it's 8 units above. I don't know, whatever. So I'm gonna do this. All right, so say we have A and B, right? Initial point is A, terminal point is B. So if I do this vector, this would be the vector AB. Well, that vector and this vector, which is B to A, clearly are related, right? So if this said, for example, let's say that this is 6, 5. Well then, if that's what you need to do to go from A to B, then to go from B to A, you must have to go -6, -5, which actually means, if you look at it, that in some ways, AB is just the negative of BA, which I feel like makes sense, right? In every sense that you have of what negative means, this I think makes sense, right? If you do AB plus BA, you would go from A to B, and then from B to A, you would end up back where you started, like nothing happened. You'd basically get 0. So another way that we could have done this particular problem is we could have said that this is the initial point. I will do this in a slightly different color. Well, in a different color. If I treat this as the initial point, and then if I use 5, -8 as my vector, I would have had, so it would be, you start at 2 and add 5, so your terminal point would have been start at 2 and add 5, 7, start at -6 and subtract 8, -14. So this actually, I think, is an easier way to do it. I don't think that I explained it in a great way, but what I did was I just noticed, like, if you have an initial and a terminal point, that gives you one vector, but if you swap them and you go from terminal to initial, you just get the negative of the vector, and you can just apply that in the same way, right? So if you start at the point, I wish I had like infinite space on these notes, which like I kind of could, but I don't really like adding pages. Also, I'm never really sure where I'm gonna add a page in here and just like draw something real quick, maybe. So here, if I have this point and then this point, right? It's like one problem goes from here to here, and then the other problem just takes you back to there. So this is your initial point for this problem and your terminal point for this problem. And then let me swap up the color here. And then here, you would have, this is your initial point and this is your terminal point. It's like the same problem. You can just work it backwards, which is essentially what I did there. So I don't know. I don't think that actually cleared it up at all. But what I'm going to do is stop this video here and come back in the next one and do some more stuff. So I will see you there.